lesson is the fifth lesson in chapter 7. The lesson is polynomials. In this lesson, we will be classifying and writing polynomials in standard form. There's a lot of definitions in this particular section. You may either copy the definitions at this time on your vocabulary sheet, or you may do it after you finish watching my video lesson. You do need to know these words, however, and we're going to start with the word monomial. Notice the word monomial contains the prefix mo and o, which means one. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. For example, ax squared is a monomial, 6y to the fifth power is a monomial, and it could be just simply a number such as 25. A polynomial is a monomial or the sum or difference of monomials. So a polynomial could include the example we talked about previously, ax squared. It could be something like 5x cubed minus 3x squared plus 2. That's also a polynomial. Polynomials have terms that are separated by plus and minus signs. So this particular polynomial has 3 terms, 1, 2, 3. The degree of a monomial can be determined by adding the exponents of the variables in the monomial. And we'll be doing an example showing you how to do that in just a little bit. The degree of a polynomial is the degree of the term with the highest degree. So remember, a polynomial can have more than one term, such as 7x to the fifth plus x squared plus 2. The degree of the polynomial would be the degree of the term that has the greatest degree. In this case, the term with the highest degree is 7x to the fifth. The degree would be 5. The standard form of a polynomial is a polynomial that's written with your terms in order from greatest degree to least degree. In the example above, 7x to the fifth plus x squared plus 2 is written in standard form because we have the term with the greatest degree first. And the leading coefficient, this is our last vocabulary word at this time, the leading coefficient is the coefficient or the number that's multiplied by the variable. So the leading coefficient is the coefficient of the first term when written in standard form. The leading coefficient for the example above would be 7. Let's try some examples. In these first few examples, we'll be looking at the degree of the monomials. Looking at the monomial 4p to the fourth, p to the third power, the degree of a monomial would be 4 plus 3. We're adding the exponents, so the degree is 7. 4 plus 3, which is 7. In this example, 7ed, we know that e has an exponent of 1 and d has an exponent of 1. So the degree of the monomial 7ed would be 1 plus 1 equals 2. One more example of this type, and this is true for any constant. Remember, a constant is a number that stands alone. If there is no variable in your monomial, we say the degree is 0. So the degree of any constant is 0. In our next set of examples, we will be finding the degree of the polynomials. Remember, the degree of the polynomials is the degree of the highest term. So, for example, in this polynomial, 11x to the 7th plus 3x to the 3rd, the degree of the first term is 7. The degree of the second term is 3. We get the degree from the exponent. So the degree of the polynomial, therefore, is 7. One-third W squared times Z plus 1/2 Z to the 4th minus 5. We want to find the degree of the polynomial. Find the degree of the polynomial. Again, we add the degrees of each factor of the monomial. So the degree of 1/3 W squared Z to the 1st is 2 plus 1, which is 3. The degree of the second term, 1/2 Z to the 4th, is 4. So therefore, the degree of the polynomial is 4 because that's the term with the highest degree. Now we'll practice writing these in standard form and giving the leading coefficient. Remember, the leading coefficient is the coefficient of the first term when written in standard form. We have the polynomial 6x minus 7x to the 5th plus 4x squared plus 9. We want to write it in standard form. When we write these polynomials in standard form, we put the terms in order from highest degree to least degree. You'll only have to do this when you have a single variable. So I'm going to rearrange this. My highest degree is negative 7x to the 5th. The highest degree is 5, but this is the first term. My next term is 4x squared, because 2 is the next highest degree, followed by 6x, followed by 9. Notice the leading term is negative because there's a negative sign in front of the 7. So the leading coefficient is not just 7, it is in fact negative 7. Another example, y squared plus y to the 6th minus 3y, written in standard form, becomes y to the 6th with a degree of 6 plus y squared. This term has a degree of 2 minus 3y. The last term has a degree of 1. We've written this in standard form. The leading coefficient. I don't see a coefficient for my y to the 6th, so we know it's the ninja 1. We know that the leading coefficient is 1. That's how we put our polynomials in standard form. Finally, we're going to classify according to degree and number of terms. To do that, we're going to go back a bit, and we're going to look at my PowerPoint. This is my PowerPoint for all of Chapter 7, which you can find on my wiki. I'm interested in this slide for Lesson 5, which contains just a bit more vocabulary. This is the table I'm interested in, and you'll be able to find this in your book. Also, you can include this on your vocabulary sheet. We can classify polynomials by degree and by number of terms. Look at the first example. We have the constant 8. The degree of a constant is 0. So if you're asked for the degree, you look at 0. It's called a monomial because there is one term. The second example, x minus 2. X minus 2, the degree is 1 because x does not have an exponent. If you have a polynomial with degree 1, we call it linear. It makes a line when you graph it. This polynomial has 2 terms. A 2-term polynomial is called a binomial. Here again, think about your prefixes. The prefix bi has the meaning of 2, so a binomial has 2 terms. The next example, 4c squared plus c minus 3. The degree is 2 because the degree of a leading term is 2. If we have a polynomial with degree 2, we call it quadratic. And we're going to deal more with quadratic equations and quadratic polynomials a little bit later. This is also called a trinomial if we're classifying it by the number of terms because we have 1, 2, 3 terms and tri means 3. One more example on this chart, we have x cubed plus 2x squared plus 3. This is also a trinomial because it has 3 terms. It's also called cubic. When you classify it according to its degree, anything to the third power is called cubic. Excuse me, I'm trying to return back to my lesson. Okay, so to finish our classification, I'm going to write on the screen right here. So for example, if you have the polynomial 5n cubed plus 4n, if I want to classify this according to degree, I look at the leading exponent has degree 3, so this one is a cubic, and it has 2 terms, so it's a binomial. This is called a cubic binomial. 2 terms, degree 3, we call it cubic binomial. We have the example 4y to the 6th minus 5y cubed plus 2y minus 9. This one has 1, 2, 3, 4. Anything above 3 terms we just call a polynomial. And anything above the 4th degree, we call a 4th degree. We call a 4th degree polynomial a quartic, but this one's a 6th degree, so we'll just say it's 6th degree polynomial. A 6th degree polynomial. And finally, if you only have 1 term, such as this example right here, negative 2x, we know it's a monomial because it's 1 term. It's raised to the first power, so we say it's linear. This one is a linear monomial. So again, we're just classifying these, and I will be helping you with that. You can also use the chart for that, so don't worry. Thank you very much. That's all for today's lesson.